Hey everybody, Ms. Teacher here. We're taking a look at question 6 from L20. It says, what is the value of k in this equation? And they give us the equation. So whenever you have fractions, either as a coefficient or even as the number on the other side of the equation, I think it's a good idea to think of reciprocals. Now, there's two approaches that we can take here. You think to yourself, what's the opposite of multiplying a variable with 2/3? And that would be to divide by 2/3. And I just want to remind everybody that dividing by 2/3 is the same thing as multiplying by the reciprocal, which if we flip this around, that's going to be 3 on top and 2 on the bottom, or 3/2. So some people would draw a line and show divide by 2/3, but it's easier to take this approach right here. So let's put that over here. And whatever you do to one side of the equation, you have to do it to the other side of the equation. Remember, we want to use our equality properties. All right, so what happens to all this stuff? This all cancels out, right? Divide by 3, divide by 2, you get 1. 1 times 1 is 1 times 1 is 1, and if we do 1 times k, we get k. All right, so the only thing left we have to do over here is just find what 45 times 3 is, and then divide it by 2. 45 times 3. Here we get the 15. Here we get the 12, plus the one more would be 13. So the numerator is 135. The denominator would be 2, because 1 times 2 is 2. So now you just have to take this number and divide it by that number, and then you'll have your answer. Now you don't have to sit around and wonder, did I get it right? Once you have this quotient, then you can go back and do a check. So how do you do a check? You write your original equation again, which recall is 2/3 k equals 45. 2/3 k, so you're going to get some number. I would suggest, in fact, maybe it's going to even be better to just leave it as an improper fraction and just see if that equals 45. And if it does, then you found the answer. And of course, you want to look for the mixed number equivalent of that. All right, so that's number 6. Let's take a look at number 7. This one's addition equation. You always want to find the variable and ask yourself, what's happening to the variable? In this case, we're adding 5 3/4 to the variable, and always ask yourself, what would be the opposite of that, or the inverse? So the opposite of add 5 3/4 to a number is to subtract 5 3/4. So we have to do that to both sides of the equation. All right, so all of this will cancel out. But this, see, we have the problem of we don't have a common denominator. So let's come up with a common denominator for that. So we're going to leave this as 5 3/4, and we're going to change the top addend to something fourths. So 8 and something fourths. How do we get the something? We have to think to ourselves, 2 times what would be 4? And we come up with 2. Do the 1 times 2, and we get the 2. Now, we can't take 3 away from 2/4, so we have to rename. Now, you have a couple options. We can turn the whole thing into an improper fraction if you like doing it that way, or we can just take the 1 away from the whole number, so make that 1 less. And basically what we're doing is the 1 doesn't go away. We're adding in the equivalent of 1, which is 4/4, to the 2/4 that we already have. And a shortcut is to just add the denominator and the numerator to get 6/4. All right, so you're going to pick it up from there. 6 minus 3, come up with a number. Put that number right here, and that's going to be over 4. And then do the 7 minus 5 and put that number here to get your whole number. Now, again, it's always a good idea to do a check. So whatever answer you get, if we go back to the original equation, you'll have your answer. Substitute it in for the place of n, add 5 3/4 to it, and make sure you get 8.5. All right, let's take a look at questions 11 and 12. It says a group made a poster that has a length of 3.5 feet. So let's draw that in our picture here. 3.5 feet. The width is 1 1/4 feet shorter than the length. So that means that if we take the length, which we know to be 3.5, we would be subtracting 1 1/4 from that, and that would equal the width. Now look at number 11. It says which equation can be used to find W, the width, in feet of the poster. Now it might be a good idea to go ahead and figure out what the actual number would be, because they do want that anyway. And that might help you also to recognize which of these in the lineup of number 11 might be right. So let's set this up in an up and down formation, because we do need a common denominator. So let's rewrite the 1 1/4. And we're going to change this into something fourths, because that'll work nicely for a common denominator. And we think to ourselves, what times 2 will give us 4? And the answer to that is 2. 1 times 2 would give us 2. And then we'll bring over this 3. Let's use red still. All right, so now we're going to go ahead and subtract these two things. 2 minus 1 would be 1 over 4 still. And then 3 minus 1 would be 2. All right, so that's a choice for number 12, and you're going to go ahead and pick that. This number matches one of the answer choices for number 12. Take a look. Now for number 11, what you're going to want to do here is you're going to want to ask yourself which one of these equations would also, if you were to solve for W, you would also get this answer of 2 1/4. So in a case like this is talking about 1 1/4 times whatever the width is would equal 3 1/2. This one is saying 3 1/2 times the width will equal 1 1/4. This one's saying if we add the width to 1 1/4, we'll get 3 1/2. And this one is saying if we take the 2 1/4, which we got for W, and subtract 1 1/4, we would get 3 1/2. So just go ahead and substitute in this value for W if you're not sure which one it is, and that's the one you're going to pick for number 11. All right, and finally, we're going to go over number 14. It says Nardia and Justin solved this problem. 6x equals 42, so I wrote it twice. Nardia says she can solve for x by multiplying both sides of the equation by 1/6. So her method is to do this. All right, so I'll just put an N so we know who we're talking about. Justin says he can solve for x by dividing both sides of the equation by 6. So Justin is doing it this way, dividing this by 6 and dividing this by 6. All right, so if we were going to proceed with Justin's method, which probably would be a little bit easier if we proceed with that, we have to make sure that we are following the equality property, which says that if you divide, the division property for equality says if you divide by the same number, the two sides of the equation remain equal. So we're going to see if that's going to help us here. So if we do 6 divided by 6, that gives us 1, and 1 times x is x. And if we do 42 divided by 6, we get 7. Now let's go back to Nardia's approach. So in her idea is she's thinking the opposite of multiply by 6 is to divide by 6. So let me put that over here. And dividing by 6 is the same thing as multiplying by the reciprocal. And the reciprocal of 6, remember, is 1/6. Because if we stick a 1 underneath that, right? Now, is that what she did? Is multiplying by 1/6 the same as dividing by 6? It is. So, same kind of thing there. We could simplify here, right? 1 times x would be x. And if we do 42 times 1/6, wouldn't we be simplifying? Getting a 1 there and getting a 7 there and getting 7 also. All right, so we need to know who is correct. Nardia, Justin, neither, or both. Explain your reasoning, then solve to find the value for x. Now we've already solved. We already have the answer to that, but looks like both of them are correct. All right, so this concludes your help for L20. Good luck on the rest of it.